don't think of smell-o-vision as a particularly futuristic technology. The idea has been around in some form or another for a long time, decades. Here's Weird Al, the one and only, joking about the possibility 30 years ago.
It's going to change our entire TV watching experience. You'll be able to watch the Food Network and smell the garlic, and you'll cry when they cut the onions. Movies will be a lot different too. You'll be able to watch Apocalypse Now and actually smell the napalm in the morning. And it'll add a whole new dimension to the eating baked beans around the campfire scene in Blazing Saddles.
But when you really do dive in, the question of why can we not really truly figure out recreating smell, well, that sounds like prime territory for us here at the Curiosity Desk. Here to make the case, we're joined by Sandeep Robert Datta. He's a professor of Harvard's Medical School's Department of Neurobiology. Bob Datta, welcome to the Curiosity Desk.
Hi, Edgar.
Let's talk about smell-o-vision.
Yeah,
Let's do it.
So smell-o-vision is this crazy idea that when you watch a movie, you should also be able to smell the movie. And strangely, although, in the next decade, we'll start building a base on the moon, we'll probably have nuclear fusion. You can get your lunch delivered by drone. We still don't have smell-o-vision. And I think that that's a really amazing thing.
Let's talk a little bit about the history of tries of this. Well, I'm always very interested in a concept. Smell-o-vision is an example of one of these concepts where people keep having the idea, right? Like independently over a course of time. Because we don't have it yet, it's not like somebody has necessarily even heard about it. It's like over and over again, a generation goes by and then somebody says, wouldn't it be cool if we could like smell the movies or smell TV? And they try and they try and they try. So take us back all the way back through to the sort of first attempts at smell-o-vision.
Yeah, so people have been trying to do this for more than a century. In the 19th century in London, folks used to go through the aisles of plays and spritz perfumes to try to give a little ambiance to the plays. And then in 1906 in Philadelphia, there was a silent film that was all about the Rose Parade, which of course features roses. And so in an attempt to spice that up, someone took a cotton ball soaked with rose-scented perfume and put it in front of a fan and blasted the audience with this rose scent. And then 20 years later, right here in Boston, in Fenway, there's the Fenway Theater. And they were playing a movie called Lilac Time, which of course features lots and lots of lilacs. And someone did the same trick, took a cotton ball and sprayed the scent of lilac into the audience. But things didn't really get moving until the World's Fair in 1939.
It's always at a World's Fair,
yeah,
right?
exactly. It's like the craziest stuff, right?
Yeah.
So yeah, in 1939, this dude named Hans Loeb showed off for the first time a device that he called smell-o-vision. And he had a little demonstration. And the idea was that somehow he would use this device, which included what he called a smell brain, to sync up scents with movies that you were watching. And he did a little demonstration of this in 1939. And things got pretty exciting because Disney the next year was going to come out with Fantasia. And so Disney thought that maybe he would incorporate smell-o-vision into Fantasia. But it turns out that he couldn't do it. And the reason why is because the other big innovation with Fantasia was, of course, that was the first movie that had stereo. Yeah. And so all the movie theaters had to get rebuilt with all these extra speakers, and no one could afford the smell-o-vision. And so smell-o-vision went onto the shelf, and we didn't think about smell for another 20 years. And then 20 years later, in the late 50s, there was a technology that was developed called Aromarama. These names are amazing, right? Aromarama. And Aromarama was a technology where basically there were a dozen scents that were blown into a theater through the air conditioning system. And so they tried this out with a movie called Behind the Great Wall, which was about the Great Wall of China. And there's lots of flowers apparently behind the Great Wall. Okay. And so they blew a bunch of perfumes into the theater, and that turned out to be just terrible. So, so first of all, the thing about scents, as you know, is that they linger, right? So you blow some scents into a room and it sticks around forever. And so imagine you're stuck in a hot theater and scent after scent is being blown in. It just is, it's awful. And so people hated Aromarama, but kind of inspired by Aromarama, Hans Loeb decided to deploy for the first time commercially smell-o-vision, his version of odors in the theater. And the way he did that was to avoid the problems of Aromarama was to put a little port in front of everyone's seat, and so each individual would smell their own little bit of odor. And so he developed a smell track for a movie that I think was called The Scent of Mystery, The Smell of Mystery, something like that.
The Scent of Mystery.
The Scent of Mystery, right. And it featured about 30 smells. And, you'd watch this movie and they'd be like little smells that were associated with the clues.
Yeah, there was like a
movie.
guy who like smoked a pipe,
Yes.
and he, every time he was on the screen, it was like the pipe is smoking. It's like, I think they're pumping in some tobacco smell here.
Exactly. But that also did not work so great. There was a
Yeah.
lot of variability in terms of the ways in which people interacted with the smells. Some people thought it was too strong. Some people thought it was too weak. And so that got dropped too. And then, my favorite, in 1981, John Waters put out the movie Polyester.
Yes.
And, John Waters famously said that his goal in life was to make movies that stink. and and Polyester was his attempt to really instantiate that. So he included along with your ticket to Polyester when you walked in, he handed out what he called odorama, which were little scratch and sniff cards that had numbers on them. It was 1 through 10. And you'd go watch this movie, and every once in a while, a number would pop up on the screen. And you'd scratch and you'd sniff one of the smells that he had included.
Here's a little moment from Polyester, 1981 film from John Waters. This is Dr. Arnold Krangenshaw previewing this newfangled technology.
Hello, moviegoers. I am Dr. Arnold Krangenshaw, and I am here to explain to you the wondrous screen gimmick, Odorama. The producers of this film have unselfishly spent untold millions of dollars to develop this startling process. And I have been locked away for many years in the laboratory, experimenting with this mind-boggling project.
We're talking with Bob Datta. He's a professor in Harvard Medical School's Department of Neurobiology. We're talking about smell-o-vision. Okay, so there's a lot in what you've said here. Let's kind of break down a couple of things. One, what is the chief challenge here in making this work? Is it understanding what people want? Is it pulling it off in some form or fashion? Or is it something to do with the nature of smell itself and why that is a difficult challenge? Let's start with number one. Is this something people want?
So this is something some people want. I think it's something that you and I want. I mean, some people are super sensitive to smells and just don't like it. And so believe it or not, there's actually a kind of weak version of smell-o-vision right now. You can go to Randolph. There's movie theaters out there where there are these fancy, I think, 40X theaters where, you sit in those seats where they move around and they spray water at you and wind at you. And it actually includes some scents. And I myself have not done this, but if you read online, the scents themselves are pretty divisive. Some people can't smell them, some people really hate them, and a few people like them. And so one thing that, as a smell scientist I know is that people's reaction to scents is incredibly personal. And the fact that all of us have different reactions to smells makes smell-o-vision a little bit of a challenge.
What is it about smell that is like that? Because, certainly I would imagine there's some variability in what people are seeing on a screen or, I would guess, obviously some people wear glasses, some people don't, right? So there's variability in vision in terms of like how well you can see or how granular you can see. But is it wider in smell? And if so, why?
Yeah, so the molecules that your nose uses to smell odors in the world are all different when comparing me and you. So your so-called olfactory genome is very different from mine and is different from everyone else's. And that variability means that the way that you smell the world is actually different than the way that I do. Also, smells are super sensitive to experience. So your personal experience with smell is different from mine. And that means maybe that you love the smell of durian, whereas I might hate that. I might hate that fruit, right?
Right.
So that accounts for a lot of the differences.
Okay. We're talking with Bob Datta. He is a professor at Harvard Medical School's Department of Neurobiology. We're talking about smell-o-vision. So, okay, people want it. Maybe, maybe not. Some people do, some people don't. The challenge of doing it, the challenge of accurately reproducing smell, is that a challenge, or is that something we've got on lockdown and that's not the problem?
Oh no, that's the main problem.
That is
And,
that
that's
is the problem with a capital THE.
That is the problem, and I think that it's such a cool problem, like because it really illuminates the way in which smell is a unique sense.
Tell us more.
All right, so I'm going to explain to you why smell-o-vision is hard by explaining to you why regular vision is easy.
Okay.
Okay, so we are really good at recording visual images and movies and projecting them. We can digitize what we see. We can project it over long distances. We can recreate it in our living rooms on those fancy OLED TVs we all have, right?
Yep.
So how can we do that? Why does that work? That works because we understand how our retina, our eyeball, sees light in the world. So you have sensors in your eye that sense 3 colors: red, green, and blue.
Yeah.
And every hue that you're capable of detecting is some combination of those 3 primary colors: red, green, or blue.
So not too many variables here. 3 of them.
3, that's it. 3.
Yeah.
And so basically, you can encode every hue as some ratio of red, green, and blue. You can digitize that number. You can send it over the internet, send it over the air, light up red, green, and blue LEDs in your TV, and recreate what you've seen.
In a very faithful way.
Exactly, right? It looks very real. So what scientists really want to do is understand whether there's an RGB for smell. So is there a set of smells or a set of chemicals that if you mix them together in just the right combination, you could recreate the entire universe of smells?
So the elements of smell.
Exactly, the elements of smell. And that's a hard challenge. It's a hard challenge in part because every molecule that you can smell has a different size and weight and shape and chemical composition. In fact, scientists estimate that there may be 1 trillion different kinds of molecules in the world.
That's a trillion with a T.
1 trillion with a T that, that your nose is capable of detecting. And so that's a very big space of things you can
That
smell.
is more than 3.
Yeah, that's way more than 3. Okay, so one version of smell-o-vision would be having 1 trillion vials with every possible smell, and then playing those all as you kind of went along.
That feels financially difficult.
Not a thing, right? But what would be amazing is if we could discover that RGB, the base set of smells that combined would create all possible scents, and then deliver them to you flexibly to create a kind of olfactory virtual reality. And that's a thing that people are thinking about now and working on pretty hard, both in the lab and in industry.
So I hear what you're talking about. You're talking about a problem that is in some ways a problem of scale. We have many trillion whatever, right?
That's right.
It is 2026. I hear problem with crunching many numbers or problem at scale, and I go, is this something for AI to solve, right? Because that's sort of where your brain goes right now. You're going, lots of data, lots of numbers. We're trying to parse through it. So how does AI play into this? It must in some form or fashion.
Yeah, Edgar, that's exactly right. So the advances that have been made in understanding the ways in which smell might be transformed by your brain into perception, most of that progress in the last decade has been made through the use of artificial intelligence. And so people are generating really large data sets. You can imagine the subjects of these data sets where people are smelling all sorts of things and describing what they smell.
Yeah.
And then machine learning is taking all that data, and people are building models that allow us to predict with some accuracy, not with perfect accuracy, with some accuracy, what a given molecule is going to smell like. And so what that means is that you can basically go to the lab, synthesize some molecule that has never been synthesized before, that no one has ever smelled before, give it to a human, and make a pretty realistic prediction about what it's likely going to smell like.
That's interesting. So when we think about when we think about this sort of problem, so to speak, as you call it, or this challenge, in terms of like saying like it would be cool if we could identify this sort of base number, then that would make smell-o-vision possible. But like obviously we would not do this for smell-o-vision. What else would it unlock if we could get better at getting to this kind of baseline of understanding of like here's our elements of smell. What does that do for us besides make a better, more affordable smell-o-vision?
Well, as a smell scientist, I'm going to say to you, the possibilities are endless.
They are amazing.
But I do think that, if we're ever going to have convincing virtual reality where we as humans sit in virtual worlds and experience new environments, smell is going to be part of that. And I just want to remind you that unlike our other senses, smell is part of our lizard brain. It was the first sense.
It's like the oldest of our senses,
Exactly.
right?
It's the first sense that evolved. And it's really deeply connected to our emotional and our memory centers. And so I'm sure, I heard on your last segment, you talked a little bit about aromatherapy.
Yeah.
Right. There's something that's real about that. We don't have a lot of data, but it's clear that different scents connect to us emotionally. And it's also clear that if you lose your sense of smell because of like COVID or something, often people are left a little bit emotionally bereft as a consequence of that. And so I think there really is the potential to enrich our lives as humans, and potentially use things, technology like smell-o-vision, to help with a variety of therapies, for folks that are depressed, and to give us a better sense of how we can, and these technologies will give us the ability to, I think, better recreate our world, which I think itself is going to be very useful.
How much how much does it compound the challenge that our sense of smell is so directly, viscerally connected to something like memory and personal experience? Because it seems like in addition to saying maybe there's 3 trillion molecules, you're also talking about a sense, and sure, this happens with touch and it happens with vision as well, but not in the same way, that very personal connection, but also the intensity of that connection to the smell, which is special. How does that compound the challenge of saying, like, how do we get to this kind of baseline?
Yeah, no, you got it exactly right. So what these machine learning models are good at is predicting how the average person is going to respond to a new chemical.
Right.
Right. What they're not great at is predicting how you or I would respond to a chemical. And that's because your grandma's kitchen smelled different from my grandma's kitchen, right? And because of that, the things we associate as being pleasant and with food are very, very different. Because of our experiences.
Another question that springs to mind now I'm sitting here thinking through smell-o-vision. So the idea of you talked about smell lingers, right? In a way that is very different than vision does not linger, right? So one of the things, a moving picture is literally a moving picture, right? It's a bunch of pictures that are going by so fast that it looks like it's moving, but they're not lingering. You see it and it's gone. You see it and it's gone. But smell, as you point out, which we all know, lingers. Why does it linger like that in a way that vision does not?
Yeah, so smells are really volatile chemicals, mixtures of volatile chemicals that in order for you to smell them have to be hanging around a little bit in the air. In the real world, we're always moving around and there's always wind. And so smell is carried to us in plumes that dissipate odors. But if you're in like a small movie theater, you're getting a bunch of odor, blown at you, the odor is going to tend to stick around. It'll stick to your clothes, it'll stick to your nose, it'll stick to everything. And it's hard to get rid of. And so one thing that scientists are thinking of, a really futuristic thing scientists are thinking of, is building smell-o-vision without odors at all. So one possibility is to somehow stimulate the centers in your brain that are responsible for responding to smells. There's a part of your brain called the olfactory bulb, and people have actually done that already in very crude ways. So you can use techniques to attach a little gizmo on top of your nose and actually stimulate neural activity in your olfactory bulb. And thus far, people have been able to elicit 4 total smells. And they're not very impressive. I think one's trash, one is air, I think one is kind of poop-like. So it's not like the whole universe of smells has been commanded, by stimulating your brain. But I think people are beginning to think that maybe to get past the problem of odor delivery, we should just stimulate the brain directly.
All right. So only 2.9999999 trillion to go. We've got 4 on lockdown. That's great.
That's
All
right.
right.